let's see if we can apply this stuff. Again, work really, really hard to memorize those, because the faster you memorize those, the better off you're going to be in this class. We will use them over and over and over again in multiple ways. Okay? So really work hard to memorize that first quadrant from 0 to 90, including the 30, the 45, and the 60 for sine, cosine, and tangent. Because if you know those, then you can take the reciprocals and then start memorizing cosecant, secant, and cotangent. So let's start with example 1 here. And notice I have triangle ABC, and I have Pythagorean triple actually involved for my sides. 5, 12, 13. There's no roots. It's really nice. It's a Pythagorean triple. Okay. What they want us to find are sine, cosine, and tangent for both angles A and B. So notice they're just asking for the big three, and they usually don't ask for the right angle because we already know that's a quadrantal angle. We wouldn't have to do any of this really. All right. So if I'm looking at angle A first, I'm going to go ahead and label. You don't have to do this once you get the hang of it. But since there's no X and Y axis, I'm going to use the opposite. This will always be the hypotenuse. And then this would be the adjacent for angle A. So for sine, remember, so that's opposite, which would be 5, over the hypotenuse, which is 13. For cosine, it's the ca. For angle A we're looking at, right? So angle A, the adjacent would be 12 over the hypotenuse, which again is 13, our longest side. And then TOA, tangent, the angle A is opposite, which is 5, over adjacent, which is 12. And that's the first half of this. Now I could actually not do the second half very easily, because I know that they're asking me for the same trig functions, but for angle B now. So the only thing that's going to change with these is for angle B, the hypotenuse will still be the hypotenuse, but now this will become the opposite, and this will become the adjacent side to angle B. So when I do the sine of B now, it's going to still be the opposite, but this time 12 over the hypotenuse, 13. And that looks familiar. Because this is a right angle, I know that angle A and angle B together are complements, complementary, adding up to the other 90. And since we just found the cosine of A, then we know the complement to that, which is sine of B, would be that same ratio. And since we have the sine of A, we can do the cosine of B as being the same, 5 over 13. And again, just to check, make sure that you know that cosine of angle B would be the adjacent over the hypotenuse, 5 over 13. So again, having this knowledge is just a shortcut to be able to find things a little bit faster and not have to go through the definitions of each of your trig functions. However, you do have to be careful with tangent, because I know it doesn't say it's cotangent of the other angle, but tangent of angle B is actually equal to the opposite over adjacent. And notice that is the reciprocal. Just again, be careful, because sometimes they'll try to confuse you a little bit with cofunctions and reciprocal functions. Make sure you know the difference between cotangent and tangent of a specific angle, all right? Because cotangent is the reciprocal. And if we're looking at angle B, it would actually be equal to 5/12, which therefore would also be equal to the tangent of the complementary angle. All right, so again, this is where things start getting a little fishy, because we're starting to add more and more vocabulary. So the better you really understand, which is why I tried to define cosine with sine as the complementary function. Remember, the complement is when two angles add up to 90. And since this right here is a right angle, then we know that this and this together are going to be complementary angles. Therefore, we can use, with those two angles, complementary functions. And we know that they would be equivalent. Now we're going to get to the second example, which actually asks us to write these random angles, acute angles, remember between 0 and 90, still in just quadrant 1, with its cofunction. So that's pretty easy because the co is embedded in a lot of these names. Now, if the co is already there, think of it as a negative, the complement to it. And if you put a negative in front of a negative, then that gets rid of it. They virtually cancel out and make it positive. So the complement to cotangent would therefore be tangent. The complement of cosecant would therefore be secant. And obviously the complement of sine would therefore be cosine. And remember, if we're dealing with complements, which is what that co stands for, then we need to take the complement of the angle for the complementary function. And so you're just looking what plus 9 would get you to 90. And hopefully you can say off the top of your head that that's 81. If not, you can always say what plus 9 takes me to 90 and then do the subtraction so that you have an equation to actually derive that answer. Okay? But I think you guys are capable of saying what plus 76 would get me to 90. And I always like to take care of my ones first and get it to the nearest 10. So I know if I add 4, I'd be at 80, and then I'd have to add 10 more. So notice I had to add 4 and 10 for a total of 14. And that would be how I can write my cofunction equivalent to each one of these. Sine of 9 degrees, cotangent of 76, and then the cosecant of 45. What would that be equal to? Well, since it's cosecant, we know it would be secant. And obviously, 45 plus what would get us to 90? Hopefully it was obvious to you. We just reviewed the 45, 45, 90. Done. Okay, so some of these are much quicker than others. Hopefully you guys understand what they're asking and then how to apply it. So our next example, very similar, but gets a little bit more algebraic in nature. They want us to find just one solution for the angle theta and assume that our angles are all acute, so between 0 and 90. And they are telling us right now that these two statements on the left and the right are equivalent. That's what it means to be an equation, right? So we're going to take what we know, which is the fact that they gave us cotangent of some angle is equal to tangent of some angle. And what do we know has to be true because it is tangent and cotangent? Well, those are complementary functions, hence the name, cotangent. And therefore, I know that this angle plus this angle will have to add up to 90 degrees by definition of complementary angles. So I'm going to take that theta minus 8 degrees, and I'm going to take that 4 theta plus 13 degrees, and I'm going to add them and set it equal to 90. So since we're asked to add, we only know how to add like terms. So I'll take the thetas first. 1 theta plus 4 more gives me 5 thetas. And then I'll take the numbers, negative 8 and 13, and subtract. 13 minus 8, or how much of a difference are 13 and 8? Add 2 to get to 10, add 3 more to get to 13. That's a total of 5. And now I can take that and solve this equation by first subtracting the 5 over, and then dividing by 5 to get my 1 theta. Now don't forget, we talked about how to divide without using long division. 5 goes into 8 one time, which would leave me with 3 left. Bring down that 5 that we haven't touched in the ones yet. And now I'm trying to divide the 5 into the 35. And I know that goes in 17 times. Now, how do you know before you plug this into my math lab if that's correct? Simply just plug it in here and here and make sure that those angles are indeed complementary. All right. I'm going to ask you guys to pause it real quick here. Try part B on your own. They're virtually the same. Hopefully you can see that we are again dealing with secant and its complementary function, cosecant. So go ahead and pause it, give it a try. All right, hopefully you were able to get the right answer. Just to make sure that you set it up correctly, we got our first angle, which is the 5 theta plus 14, that we should have added to the other complementary angle. And therefore we know that those two together would add up to 90. Combining our like terms, 5 theta, 2 theta, 7 theta, 14 minus 8 would be positive 6. Now we're going to take and solve this equation for theta, our unknown variable. Subtracting that 6 gives us 7 theta on one side, 84 on the other, and then we'd have to do our long division again by dividing by 7 to get that 1 theta, and long division without so long, we divide into each piece. 7 goes into 8 once with 1 left over, bring down the 4, 7 goes into 14 twice. So hopefully you got theta is equal to 12 degrees. If so, well done. Let's continue on to example 4. So we've already kind of started this earlier when I was deriving this proof for you with the special right triangles, but I want you to find all 6 trig function values for this 30-degree angle. And all we need is either our chart or to be able to draw out that 30-degree angle. So I'm not going to build the chart for you again. I'm simply going to draw my right triangle, this special right triangle that we should know their length values. Opposite the 30, remember, was our smallest one. Opposite the 90 was our biggest one, which was twice as big. And then opposite the 60 was right in between them at root 3 times as big. Again, if you want to put the A's, that's fine, not necessary. But now we just need to do our SOHCAHTOA for our big 3. And once we have those, then we can use the reciprocal for the others. Again, memorizing these, super important, because then you can look at this, boom, tell me the answer, you're on to the next part, which we will have. So the sine of 30, remember sine of any angle is the opposite over the hypotenuse. So for us, the opposite of 30 degrees, which is the angle we're looking at, would be 1 over 2, 1/2. And since I know that, I can go ahead and do the reciprocal of it and find cosecant, which would be 2 over 1. Next, I'm going to find the cosine of 30, which, remember, the cosine is the adjacent over hypotenuse. So now I'm looking at root 3 over 2. The only bad part about that is when I take it and flip it, I have a root on bottom. So now I'm going to have to multiply by that fancy 1 of root 3 over root 3 to get 2 root 3 on top, but square root of 9 or 3 on bottom. And so that, unfortunately, is what secant's ratio comes out when we're dealing with 30 degrees. And then tangent, remember, is the opposite over the adjacent. And so for us, that means we would have to do one more time a rationalizing of the denominator by multiplying by our fancy 1 to get root 3 over the square root of 9, which is 3. Now, before I actually take this and do the reciprocal, I'm actually going to take what I originally had, which was 1 over root 3, and just do the reciprocal. So I don't have the rationalized equivalent. I will just take root 3 over 1. And that is what the 6 trig function values for the 30-degree angle would give us. Now we could also find what it would be for 60. We could do something similar for 45, but again, I already showed you how to do that pretty quickly. All right. I also gave you the chart of all of these up above if you wanted to rewind the video and make sure that you take that into your notes. So that's all I got for you. Make sure that you practice these. Most importantly, make sure that you memorize how to come up with those big three trig functions: sine, cosine, tangent, acute values from 0 to 90. 30, 45, and 60 are special rights. Okay? Here's a list of all of them, excluding the 0 and 90 quadrantal angles. All right? Work hard, memorize these as quickly as possible so that you can continue to move forward and progress as we continue to add things. It's been a pleasure. Talk to you all soon.